talk to you post-harvest abiotic stresses that are used to increase nutraceuticals in fruits and vegetables. Let me start by telling you that chronic diseases such as certain types of cancer, diabetes are among the main causes of death worldwide. But guess what? A solution for these diseases might be in what we eat. Okay, nutraceuticals such as antioxidants are compounds found in food that show preventive and therapeutic activities against these diseases. Within antioxidants, we can talk about vitamin C and E, carotenoids such as lycopene in tomato or beta-carotene in carrots, or phenolics such as anthocyanins in berries. Therefore, increasing these compounds in horticultural products is desirable, and we can achieve this by applying post-harvest abiotic stresses. So what are abiotic stresses? They are adverse conditions such as UV light radiation, modified atmospheres, wounding, and when we apply these stresses on a horticultural crop, as we can see in this picture, we expect to affect the pathways involved in the biosynthesis of terpenes, phenolics, nitrogen-containing compounds, which are related to an increased functional property in the crop. So the result of this process is an enhanced product that can be sold as such in the supermarket, or it can be processed into juices or fresh cuts. Also, the pharmaceutical industry can use this enhanced crop to obtain supplements out of it. So it has been found that wounded tissue of carrot exposed to hyperoxia showed an increase of over 300% in phenolics. And it is well known that phenolics are the compounds with the highest antioxidant activity value in fruits and vegetables. So this is good. Other crops such as strawberry, blueberries, Chinese bayberries, as we can see in this picture. Okay, these crops have also been exposed to high oxygen atmospheres to successfully increase their phenolics. So it's a great thing. Prickly pear, a fruit that is common in the desert of Mexico, is rich in betalains, other compounds that show high antioxidant activity. And it's been found that wounded tissue of this crop exposed to UV light radiation showed an increase not only in phenolics but also in betalains and ascorbic acid, which is vitamin C. This is a simplified explanation of how wounding and hyperoxia stimulate the production of phenolics in fruits. So upon wounding, the cell is disrupted, and then ATP is released into the extracellular matrix, and then it diffuses into adjacent cells. Here we can see how this ATP molecule attaches to a receptor in the membrane of the healthy cell, increasing the concentration of calcium, which triggers the activation of this enzyme that transforms oxygen into superoxide, and then this is converted into hydrogen peroxide by this other enzyme. These two are reactive oxygen species that act as signaling molecules that increase the respiration rate in the mitochondria. And when this happens, the levels of reactive oxygen species get even higher, and these are toxic for the cell. So apart from these detoxification mechanisms, another pathway is activated, phenylpropanoid metabolism, to produce phenolic compounds such as chlorogenic acid and ferulic acid. And hyperoxia increases the respiration rate in the mitochondria, producing even more reactive oxygen species, and therefore we get more phenolic compounds. Okay, just to conclude, I'd like to remind you that post-harvest abiotic stresses can be used to enhance horticultural crops in terms of nutraceutical content. But we have to understand how different crop tissues and their specific secondary metabolic pathways respond to different abiotic stresses that can be used in combination. And this is the basis for strategies to develop tools that allow us to produce supplements or additives for the food industry, or healthier, fresh, or minimally processed products such as juices or fresh cuts. Thank you very much for your attention.